Assalamu alaikum and very warm welcome to all of you. In this lecture, you will learn what is time shifting, both time shifting to the left and shifting to the right. So we'll start visually and then we develop its mathematical notation. This is the original signal which we want to shift. So you understand it is denoted by x of t. So x of t is your original signal, and you can easily spot that this signal has non-zero value from this point is -3 on time axis, right? You understand this is 0 time, on this side this is the positive time, and on this side this is the negative side of the time axis. So this signal has non-zero value, that is, you see this is -3 points, so -3 onwards towards infinity it has value of 0, and similarly this is the +3 point, and +3 onwards this signal is 0. Okay, so that means this signal is non-zero only from -3 up to +3. So that's the original signal which we want to shift. So let's first observe graphically how the shift is, and so I've plotted both the signal up and down. That's the original signal, and this signal is shifted by 4 units. Okay, so you can observe that original signal was from -3 up to +3. Now I have shifted the signal 4 units, so now this shifted unit exists from +1 up to 7. So hopefully you understand shift means we are shifting the signal along this axis, which is time axis. Okay, so this signal can be said to be shifted version of this one, and this is 4 units shifted right. You understand this is your origin. Okay, so if we move this direction, this is right, and if we move in this direction, this is the left. So hopefully you understand this is the original signal. So now the shifted signal is this one. Okay, let me take, okay, so this is the original signal and this is the shifted one. So you understand, because this is your reference point, so the signal seems to be shifted to the left side. So this may be called as the shifted left signal, or actually it is called the shifted left. So you can again see that originally this point was at 3. Okay, at time equals to 3, this signal this point was here. Now if you look at carefully, this signal exists from -1. So, and this point, okay, this point was originally -3, and now you see this point is uh, 7. So that means this signal is actually shifted to the left 4 units. So hopefully this graphical representation gives you the idea. So in the next slide we start with the mathematical treatment. So the original signal, okay, mathematically we can say the original signal is defined x of t here. Okay, x of t equals to t for the interval uh, -3 up to 3. So okay, this is the uh, original signal definition. Mathematically we say x of t equals to 3 and the interval is -3 up to 3. Okay, and we denote the shifted signal by y of t, and we say y of t equals to x of t minus t naught. So you understand t naught basically represents the shift. So if t naught is greater than 0, then we say the signal will shift right, and if t naught is less than 0, then we say the signal will shift left. Okay, so if we look at this one, the signal definition, when t equals to 0, okay, at t equals to 0, the signal becomes 0. So we say that basically this signal is a straight line signal centered at 0. So this is 0. Okay, so if we move in the negative direction, it has negative amplitude, and if we move in the positive direction, then it has the positive amplitude. So let's do the stepwise transformation for the right shift. Okay, so again, for your reference, I've shown the signal mathematical definition here, and you can see it. Okay, so this is the value of the signal, and this is the interval. So let's repeat the same example as shown graphically in the previous slides. So mathematically, we write the shift as y of t is the shifted version of x of t, and we say y of t equals to x of t minus t naught. Now, if t naught equals to 4, like I said in the previous slide, if t naught is positive, then we shift right. Okay, so now t naught is 4, so 4 is positive, so y of t is equal to x of t minus 4. So that means signal moves to right 4 units, okay, because t naught is positive, which is 4. So let's do the step-by-step mathematical procedure for this one. So original signal minus 3 to 3. Now because shift is plus 4, so we replace t by t naught. Okay, and because t naught is 4, so we replace t by t minus 4. So let's start with the this range, the interval. So I replace t by t minus 4, so t minus 4. Okay, now if we add 4 to everywhere, so plus 4 and plus 4, that means minus 3 plus 4 becomes 1, and t minus 4 plus 4 becomes t, and then 3 plus 4 is equal to 7. So that means the shifted version of the signal will have interval 1 to 7. So the time shifted signal it will become as y of t, and y of t is equal to x of t minus 4, because x of t is equal to 4, so replace t by t minus 4. Okay, why t minus 4? Because we say the shifted version is t minus t naught, and t naught is 4, so t minus 4. So that means everywhere we will replace t by t minus 4. So we replace here in the interval, so the interval becomes now 1 to 7. Similarly, we will replace its definition, which is equal to t, so t minus 4. So now the shifted version will have this mathematical definition, that is y of t equals to t minus 4, and its interval is from 1 to 7. Okay, so here plotting the mathematics we have just used. So original signal is x of t, the right shifted signal is y of t, which is equal to x of t minus 4. So this is the graphical representation, okay, and the mathematical representation we have just done. So let's take another example, and that is we shift the same signal, the original signal x of t, which is equal to t, by 4 units to the left. So the equation or the formula for time shift is y of t equals to x of t minus t naught, because now we want to shift it by 4 units to the left. So I will take t naught equals to minus 4. So the shifted function y of t will be equal to x of t minus 4. So x of t plus 4 plus 4. So that means we will replace t by t plus 4 everywhere present in the signal, whether it's if it is in the definition of the signal and also in the interval. Okay, so because the original signal is x of t, so that means in the definition t should be replaced by t plus 4. Similarly, in the interval will also have the same replacement, and that is t will be replaced by t minus 4. So in this way signal will move to the 4 units to the left. Okay, so original signal interval is minus 3 to 4. So if we replace t by t plus 4, then we have a t plus 4. Okay, so again not subtracting, in fact adding. Okay, adding plus 4, yes, subtracting 4 everywhere. Okay, so minus 3 minus 4, t plus 4 minus 4, and 3 minus 4. So it will be something like this, and it will become minus 3 minus 4 is minus 7, and 3 minus 4 is minus 1. So the shifted signal will have the complete definition, that is y of t equals to x of t plus 4, which will be equal to t plus 4, as x of t is equal to t, so we replace t by t plus 4, so this one. And again you understand about the interval, so you understand that when we shift we replace t by the t minus t naught value. So if it is in the definition, then we will also replace here, and if of course in the interval it is, so it should also be, it must also be replaced. So for this signal again shown here is the shift left. Okay, so you understand that originally it is minus 3 up to 3, but shifting it by 4 units, you understand in the previous on the previous slide that its range becomes minus 4 minus 7 up to minus 1. So this point is minus 7 and this point is minus 1. Hopefully this gives you the idea of time shifting. So in this lecture you learn time shifting, and you understand the time shifted version is represented by y of t, and y of t equals to x of t minus t naught. And again, if t naught is positive, then we have the shift right, and if t naught is negative, then we have the shift left. So you understand we are just shifting the signal along the t-axis. We are not making any changes in the amplitude. So we have seen it graphically and mathematically, and we have also explained how to modify the limits of the interval step by step. So homework is add original signal plus shift left signal and shift right signal and plot all the resulting waveform. So the next lecture will be on the uh, discrete time signal shifting. And you understand this lecture is part of Signals and Systems for Foundation course with Python. So that's all from my side. See you in the next lecture. Goodbye.